Everyone, thanks for joining our weekly demo day from unSkript. It is Wednesday, June 14th. We're back again with our favorite demo engineer slash developer relations slash all around good guy, skier, whatever you want to think of him as, Doug. The focus of these demo days, again, just for those that are new here or showing up for the first time, the focus of these demo days is to really just help SREs and technical support people understand some of the use cases that they're out in the marketplace right now, or people are experiencing frustration with, I guess. And then ultimately using the unSkript product to help to facilitate just a faster, easier, more simple way of dealing with those potential issues. So if you go back the last couple of meetings we've had, we've done other kinds of use cases, again, that are all about kind of cutting down on busy work for SREs. And this is another version of that. So Doug is going to take us through a couple different scenarios here for why this run book might be super useful for folks. The high level is that it is all about recovering a Kubernetes cluster from a data corruption event of some sort, database data corruption event. This is a real use case from one of the unSkript customers that this particular runbook was built for, and again, can be used by anybody else that wants to use this for, again, the scenarios that Doug will walk through here in just a second. So the focus today is this particular use case, and we're looking forward to hearing from Doug and then showing you how unSkript can kind of walk through and automate and simplify this process for folks. So Doug, with that, I'll turn it over to you.
All right, thanks, Rob. So again, we're going to talk through this Kubernetes. It's a high availability cloud backend for a database product. And it's all built on top of Kubernetes. We've got a bunch of nodes in our namespace. And there are a bunch of different reasons you might need this runbook, right? If there's a data corruption of some sort, and you need to sort of reset your cluster so that things are humming again. And so there are a couple scenarios that this runbook was built for. And one of the cool things about using Jupyter notebooks for your runbooks and for your automations is you can add these sort of text or markdown fields into your runbook describing like what the heck is going on. And that's really, really useful because anyone could come in here and say, like, is this the right, I think this is the right one for what's going on. You can say, oh yeah, I've got a couple alpha nodes that are down, right? So we need to fix this. And this runbook can walk you through the steps. You might have a data corruption, in which case you need to find the one node that has, in this case, there's 3 alpha nodes. So if 2 of them are bad, you still have one good one. So let's find that good one, back up the data from that good one, and then reset the whole cluster so that, you're back up and running with 3 nodes with good data. You might also need, if the whole thing might be screwed up, and you might need to get a backup from like an S3 bucket. That's the example we have here. Clearly, if you're using a different backup mechanism, you could change that from an S3 bucket. So there's a whole bunch of different ways you can use this runbook, and this runbook is used by our customer. It's a fairly long runbook. If you look right here, you can see the dot here in the scroll bar is pretty small. There are 17 steps. We're going to walk through it pretty quickly. I'm going to highlight the ones that are really important, and then we'll run some of the steps, and I'll just say, like, here's what we're doing here, but they're not quite as important. All right, so the first thing we're going to do is we're going to set the Kubernetes context to our EKS cluster at AWS. We're actually going to skip this step. And the reason we're going to skip this step is the demo cluster we have at unSkript is being hosted at GCP. So it doesn't even make sense to set it up for AWS because we're running this cluster inside Google Cloud. The next action I'm going to run here is called the obfuscator, and this actually has nothing to do with the runbook. The reason we're doing this obfuscator is that the output has our customer's name in it. And so here's my test, and what it's going to do is change the name of the company to database, right? So that way, we're protecting our customer. It's kind of fun too. All right, so that's the only thing that we're doing that we're changing from this runbook from actually running it in production. The first step we're going to do is we need to And I'm just gonna, you can see the output is here from when I last run it, so we can just reset those. The first thing we need to do is we need to get all of the pods in our namespace. And I've programmed our namespace as an input parameter here. And so I run this, it's gonna get a list of 6 pods in our namespace. And you can see it's database. So, our customer's name is in here. We have 3 alpha pods and we have 3 worker pods numbered 0 to 2. We're going to create a JQ command here. And we're going to find the leader of our alpha and our worker nodes. And so this is thinking and going through, and it says here that our leader is alpha 0 and worker 0. This next action is just a simple worker action, and it's rolling through this data here to get the name of the leaders. And again, it gets the name of the leaders is
So
alpha
Doug, just
0.
a quick
Yeah.
quick question for you here. Are these first few steps, would you consider them to be kind of like almost health checks that would be running in the background in order to get some information? Or is this as soon as we've been notified by the observability tools or whatever that the cluster or the nodes are down, that we would just run it from here to kind of just kind of set the context, I guess these first few things are setting the context.
This is sort of so I think at this point we know that we are about to run some backups and reboot the cluster. This is just collecting the data, right? There's some stuff that we need to know about our cluster, right? We need to know the names of all the pods. We need to know the leader of the pod, of the alpha pods and of the worker pods. So this is sort of just like, we're alive in production, but things are busted. Let's collect the data we need to resolution. So this is simply
Okay.
collecting the data we need. So we're getting the name of the leaders. We're then going to collect some data from the worker nodes, and I'm just going to run these. It doesn't. You can see the output is here. This is again when we restart these nodes, we need to put this data back in. So we're just getting the data from production now so that when we restart it, we can feed this information back into the system. And so now we're just going to set up some backups. And so what we're going to do is we're going to back up all of the databases in there. And you can see we're going to name our backup to be today's date, 6/14/2023. We're going to find our good alpha. So which one of our 3 alpha nodes has a good database, and it's saying that the good one is at alpha 0. These next 3 steps, we only need to run if the good alpha is not the leader, right? Like, so this is just moving data around so that all the good data is on the leader. You'll see that these are all going to get skipped. And the reason they're going to get skipped is because the leader is already alpha 0. And so now we're going to, I think this one is just showing all of the backups that we have. And you can see how often I've run this as a test run book in our test cluster, right? Been running it a bunch of times here in June. The next step we're going to do is we're going to create backups for the W folders and the T folders. And so we're going to create a 6/14/2023 backup for W and T, sort of like we have up here. And so this is just creating those backups. And it's going to do it on all 3 nodes. And so this action is actually iterating through alpha 0, alpha 1, and alpha 2 and doing the work on all 3 of them. I'm not showing the output here because if I display the output here, it actually shows the name of the nodes, and I haven't figured out how to obfuscate that out. So then we're going to do the same thing with the T's. And then we're going to back up the P folder on the non-leaders. And we're all set. It backed that up on 2 of them. If we come back up over here, we'll probably see, if we rerun this one, we'd see a T and a W with the date. Right, so now we see the W and the T. We've created those backups. So one thing cool about this is that once you've done the work, if you can go back and check that it's happened by looking at previously run steps in the runbook. So again, now we're looking in the target. This is sort of getting the data again, just making sure the data is all here. Creating our nodes, getting our target nodes, and getting the leaders again. This might be slightly redundant. We could probably take some of these steps out because we've already done it once. But again, we're just parsing this data and working through all of this. So now the next step is we can clean up all of the zero pods, the worker pods. So we've backed everything up, and now we can start cleaning up the pods and restarting, spinning it down to 0 and then spinning it back up again. So you can see here, when you don't run them in order, I didn't actually create the cleanup command here. And so this step failed. So now that I've run the step, this action will run. It shows the importance of when you're doing these things, it's important to do all of the steps in order. And, when you have a run book, if production is broken and stress levels are high, it's really easy to skip a step. Here I am just skipping a step when I'm talking to a few people online. So again, this worked. It passed on all 3 iterations. We cleaned up those pods. So now we're ready to scale down. So we're setting our targets, and this is setting the target cluster. So now we have the target cluster set up. We're just spinning it down and spinning it back up into the same cluster. So now we're going to scale down our alpha from 3 nodes to 0 nodes. So it's scaled. And now we're going to scale down the 0 group or the worker group to 0 replicas. And if I click right here, we're still at 3. So we had 6 nodes, we're at 3. It's scaling down, right? If I run this again, it'll be a smaller number, 2, right? Stuff is getting turned off in our Kubernetes cluster. And now it's gone, right? We're now ready. We've done a backup of everything that was good, and we've removed everything. And so now it's time to scale it back up. Let's start rebuilding our database, our Kubernetes database cluster, so that we can be back up and running in production. So everything's gone, and now let's scale it back up. The first step is we can scale our workers back up to 3 replicas. And so this step is just going to scale them back up. And if we hit this really quickly, we'll see there's still 0. And so this, in production, you could have this polling like until the number turns 3, and then you can continue on. In this case, I'm just running it manually because we're here watching it. So we've got 1, 0. We've got 2. And so in a couple seconds, we'll be up here with our third 0. Or worker. So now we have our workers set up, right? So the workers 0 through 2 are now all built back up. When I run this, it's going to say, yep, we have 3. So now we've run those parameters. We have our workers back up to 3, and now it's time to scale up the alphas. And in this database system, we need to scale them up 1 at a time. So we're going to scale up 1. We're going to make, in production, you'd make sure it's still streaming. It starts streaming the data before you spin up the second one and the third one. Just because that can take a while, we're going to skip the fact that it's streaming. This, isn't actually a production cluster. There's no data running on it. So we'll run the steps to make sure it's streaming. It will probably throw an error just because we're going to spin one up, make sure that it's running, spin up the second one, make sure it's running, and so on. So we're going to scale up that first one. And this number will be 3 initially, but we want to wait till it gets to 4. So we have the 3, 0 worker pods running, and now we want to get up to 4. All right, there we go. This is just a check to make sure that that number is 4, and it is. So we've got our 4 pods here. These next 2 steps, or these next 3 steps, we can actually skip. And so the reason we can skip these 2 steps, these steps might be because your P directory is corrupted and you want to, or there's something wrong with it and you want to install from a backup on S3, this one would copy the P directory from S3 into your good alpha, your one alpha you have running. And then when you spin up alphas 1 and 2, it would propagate across. We're not looking to restore one from S3, so we're going to skip that. We also, again, don't need to set this context because we are not at AWS. All right, so now let's see that that our pod alpha pod 0 is up and running. We can see that alpha 0 is up and running. It's been running for 2 minutes. Here's where we should wait for a snapshot, and we probably won't get a snapshot at this point. And so you can see we got an error that there's no snapshot. If you look up here in the docs, it says it can take up to 30 minutes for a snapshot to appear, and we just don't have time for that. So we can skip through that. We can assume that it will have started streaming. And now we can scale our node to the second replica. So if we click this, it's going to fire up. We have alpha 0. This is going to fire up alpha 1. And we're looking to see if it is streaming, and it won't because we haven't waited long enough. But let's just verify that we have 2 alpha pods, and we do. So that second alpha pod is now spun up, and now finally we want to get back to normal state where we have 3 of these alphas. And so now we're going to scale it up to 3. And when we run this, it'll probably say 5 right now, but we're going to wait until it says 6. Okay, so now we've got all of our pods set up in the new namespace. And so this is just another verification step. Make sure it's all there. Okay, so it's all set up. Everything's up and running. We can now do some post-recovery verification, right? Everything is up and running. The runbook is completed. We've used a bunch of actions. There were a lot of steps in this runbook, right? It's a fairly complicated problem where we have a Kubernetes high availability database that had some issues. And so we ran a backup of everything. We made sure that we had one good copy of all of the folders, saved those in the appropriate places, spun it down. And then when we spun it back up, those were in all of the new pods that were created, and we should be up and running again.
So Doug, question for you. Let's say I was the only person or one of 2 people on the SRE team, and I had a whole bunch of other stuff that was on my plate, but this was one of the top things, obviously, that I needed to fix. Could I go, I mean, from what I saw there was very little, if any, input from the user except hitting the run action button on the different steps. Is there a way to like start at the beginning and say, just run everything and I'll come back in 20 minutes and check to make sure that this run book completed?
Yes. So I'm running this in the open source, but in our enterprise version, there is a run book, and you can just run the whole thing all the way through. A couple things that we would have to do additionally to make that work is, as you saw here, when I had to verify that we got to 6, in our configuration, we can set a poll. And so we could set it to poll until, the output value, the number value, we could make sure that it's 6. And so we could poll, for 5 minutes just to make sure, keep going until this value is 6, and then move on ahead.
Okay.
That isn't implemented right now just because it's being run manually at the moment. But if you were to run this if you wanted to run, I guess there's 2 parts to that, Rob. One is if you ran this manually, or if you ran this, if you did run this automatically, you might want to skip some of these steps where you're like restoring from S3, because you may not need to restore from S3. So you could come into the configuration and, well, actually, here's where this is probably writing the command. And in this configuration, you could skip this step. You could just say, we're going to skip this step because we're not backing up from S3. Creating the command, that's trivial. It's actually doing a backup from S3 that would break things. So There would be a little bit of setup that we would need to do to run that, just like let it go without human
Okay,
intervention.
great, thanks. Um, yeah, so I think you covered everything here that I think is really relevant to, again, SREs or tech support folks.
Mhm.
You know, just to recap, Doug, what Doug showed you here is a Kubernetes cluster that had bad data effectively within it. What we did is we spun down those, we backed up the data, spun down the cluster, and then reinstantiated the cluster with the right data on it, good healthy data, good healthy pods, um, and ultimately at the end, had our system back up and running here within a few minutes. Again, there was some checks there that would happen. Snapshots would take maybe 30 minutes or so, but generally speaking, got it up and running pretty quickly. Again, the whole idea here is just to make this much simpler process. Again, what Doug said is really, in our minds, very true as well, which is like just not skipping steps, not forgetting things when you're in kind of the heat of the battle, so to speak. And then ultimately just making portions or even all of this in an automated way so that you don't have to sit around waiting for steps to run. You could actually run this all at once and go off and do something else potentially that also may require your time and energy, especially in a situation or organization that has only a couple folks doing this kind of work. So that's pretty much it for today. Again, we're doing these every week. Next week, we'll come back with a new use case that, again, really is all about simplifying and taking away the busy work from folks, while at the same time making their job just a bit easier and their lives a bit easier in the SR in the site reliability or tech support world. Thanks for joining us, and thanks again, Doug, for everything you did here on this one. We'll see you guys next week.